Okay, part 2 of lesson 1.6. This is all about transformations. It seems that most of you have a good grasp on transformations. So in general, I'm just going to write the form of a transformed function. So we have f of x. I'm just going to go ahead and put in So just to remind you, now in pre-calculus, I know you're used to x minus h. In pre-calculus, the curriculum has us write x plus h. Okay, so A, you should be very familiar, is a vertical stretch compression, also called a dilation. B, let me make this a little bit bigger. So B is a horizontal stretch or compression. H moves the function from side to side, so a horizontal shift, and K moves the function up or down, so a vertical shift. All right, let's take a look at how we do example 1. You have to use the function f of x equals the absolute value of x and rewrite using the rule. So for A, we have f of x minus 2. Right here we're talking about h. Minus 2 means we're going to move our function right 2. And let's go ahead and use it with the absolute value function, so x minus 2. All right, you should be able to do B. What's that going on there? C, we have f of negative x. Negative, remember negatives are always reflections. Let's start a little note up here. Negatives indicate reflections. When it's inside the function with the x, it means a horizontal reflection or a reflection over the y-axis. And when it's in front of the function, it means a reflection over the x-axis or a vertical reflection. So here, it is inside the function, so this is a horizontal reflection. Okay, so let me write the function. All right, and we can simplify this. The absolute value of negative x is the same as the absolute value of x. And I want you to think about the rule here. This is an even function because function of negative x equals function of x. So think on that for a little bit. Okay, then we have a reflection again. Negatives mean reflection. Here, this is a vertical reflection or a reflection over the x-axis. So in other words, we're going to put a negative out front. Okay, and I would like you to do E and F. You can check your answers with the key in the classroom. Okay, let's just review how, if we're given points, we can find points again after we've had a transformation to them. So I want you to think, let me find a space somewhere here. Okay, I'm going to write over here. So let's take a look. What kind of transformations affect our x coordinate? So what do you think about what affects our x coordinate? Well, a reflection over the y-axis. That affects our x coordinate. Also a horizontal stretch or compression. And also a horizontal shift. I'm sorry, I think you can probably hear some banging. The cat's trying to get out. So, affects the y coordinate. Goodness, I've not written a good thing there. Coordinate. Oh, goodness, let me see if I can just fix that coordinate. I'm sorry. Feeling just a teensy bit rough. Okay, now what transformations affect the y coordinate? Well, all the rest of them. A reflection over the x-axis, right, it goes from above to below or vice versa. A vertical stretch or compression, and then finally a vertical shift up or down. So these things affect the y coordinate. All right, let's take a look at a couple of examples here. We have to find the coordinates for A, B, C, D, and you've got those on the graph, right? A, B, C, D. Perhaps we should list the points here. So we have A is -4, -2, and B, we'll do them in the same order they do them here. B is -2, -2. C is 2, 2. And D is 4, -2. All right, so let's take a look at the first one. We have f of x equals f of x plus 3. All right, what does plus 3 mean? Well, you should know that it means we do a vertical shift, right, up 3. Vertical shifts, go back to our little guide over here. What does that affect? Vertical shift affects our y coordinates. So all of our y coordinates will be moved up 3. So our rule here, I'm going to write the rule here. So x coordinates, they don't change. So the x coordinates will be exactly the same place, but my y coordinates are going to map to y plus 3 because the whole graph is moved up 3. So look at your coordinates. A is -4, -2. X does not change, but y has to go up 3. So -2 plus 3 is 1. All right, maybe we'll do another one. C is, the coordinates are 2, 2. Our x does not change, but our y coordinate, we're moving everything up 3, so it will be 2 plus 3. So we have our new coordinate. All right, so you should be able to do what? Same rule to do B and D. Okay, maybe we should just take a look at one more. Let's take a look at B. So we have our function here, -2 times f of x. Think about the transformations. Negative means it's reflected over the sorry, excuse me, over the x-axis, and 2, so reflection over the x-axis. And this 2 here, this is a vertical stretch, or compression is actually a stretch here. Or we might use the word dilation. Okay, so what's happening? Now, do any of these things affect our x-coordinate? No. A vertical stretch and a reflection over the x-axis only affect our y-coordinates. So our x-coordinates will stay the same, but our y-coordinates, we have to do negative because we're flipping it, and we also have to multiply them by 2. So we're going to go ahead here, and our y rule will be y maps to -2y. All right, so now you can go ahead and write your new coordinates for A, B, C, and D, and I'm going to leave you C to have a go by yourself. Okay, let's see. Oh, there's a D as well, and you can write the function rule here. This is going to be a piecewise function. We have 3 lines on here. Remember, I'm going to get you started. Find the equations of the 3 lines, and then go ahead and write the rules. Which x values do they apply to? All right, last one. The multiple choice here. I would like you to have a go and try it. You can go and take a look at the key. It is fully worked out in the key if you're not sure, but see if you can figure it out from the verbal description. Okay, that's it. Good luck.